Hi student, welcome to this new video, still on the Laplace transform, but our focus is on the step unit function. In this video, we will show you how you can find the Laplace transform of the unit step function. Regarding the unit step function, remember that in the previous video, we said that a unit step function ut minus a for a given number is defined as 0 if t is less than a and 1 if t is superior or equals to a. Let's call this equation 1. Now, how do we therefore find the Laplace transform of a unit step function? Let's look at this theorem. If f of s is the Laplace transform of function f of t, and then we have that s is superior to a and superior to 0, then the Laplace transform of f of t minus a ut minus a equals to exponential minus as times the Laplace transform of s. Now, let's call this equation 2. You may ask yourself, where is this equation 2 coming from? We can easily prove this by implementing the following calculation. If we want to find the Laplace transform of this, right, we have that Laplace transform of f of t minus a ut minus a, right, is equals to the integral of 0 to infinity of f of t minus a ut minus a e st dt. Now, you agree with me that we can split this integral between the two interval of t less than a and t superior to a, so that we can employ the definition of the unit step function. So this will give me that 0a of f of t minus a ut minus a e minus st dt plus integral of a to infinity of f of t minus a ut minus a minus st dt. So when I look at the definition of the unit step function given in 1, I realize that when I have the interval from 0 to a, I'm less than, t is less than a, so this is 0. And when I'm the interval from a to infinity, that is t is superior or equal to a, I'm 1, so this is 1. So in finality, I will have that this integral will be equal to this, to integral of a to infinity of f of t minus a est dt. Right. How then do we have this integral? If we apply a change of variable here, right? If we have that u changing of variable, if we have that u equal to t minus a, right? What does this give? And we have that du equals to dt, right? And we see that if t equals to a, if t is a, then u will be 0. Then we have that t equals to u plus a. Applying that to this integral, right? We have that integral from 0 to infinity of f of u, right? Exponential minus s of u plus a exponential, dt. Okay, so this is dt. So I can split this sum here and then remove the exponential minus as, give me 0 to infinity of f of u exponential minus us du. And we can quickly see that this is the Laplace transform of f of s. So this integral will give me finally that exponential as times Laplace transform of the function of time s. So it is important for you to know that even though at the very beginning we have f of t minus a, the Laplace transform that we find will be the Laplace transform of f of t, not f of t minus a. Now, let's quickly look at this example. Find the Laplace transform of ut minus a, right? So Laplace transform of ut minus a, right, is also Laplace transform of 1 times ut minus a. Okay, so, and here we consider that f of t, right, is 1, and remember that it's equal to the exponential times the Laplace transform, so of f. So the Laplace transform of 1 is what? Is 1 over s times exponential minus as. Now, if we look at example 2, second example, find the Laplace transform of the function f of t, and f of t is equal to 0 if t is less than 1, and t squared minus 2t plus 1 if t is superior or equal to 1. So you have to find the Laplace transform of this function. Now, how will you do that? How will you approach this? You will realize that you will need to write this, right, as a unit step function. And to do that, we can easily see that this function f of t can be written as u t minus 1 times t squared minus 2t plus 1, right? Yes, because we see that if t is less than 1 is 0, and if t is superior to 1, right, the unit step function will be 1, and then we will remain with this function. Now, we also know that computing the square of this, we have t minus 1 squared plus 1. So at the end of the day, we will have that our function can be written as u t minus 1 squared plus 1. Now, the finding therefore the Laplace transform of this function would therefore be that the Laplace transform of f of t will be equal to the Laplace transform of u t minus 1 times t minus 1 squared plus 1. Okay, so we see that this is the Laplace transform of ut minus 1 times t minus 1 squared plus the Laplace transform of ut minus 1. Okay, so applying the formula given in this equation 2 here, I can see that I have ut minus 1 and I have t minus 1. So this is f of t. So I should find that this is f of t minus a as given here. So I should find the Laplace transform of f of t, not f of t minus a. So this will give me the Laplace transform of t squared, right? And I know that the Laplace transform of this will give me minus s, because a is 1, plus, yeah, I will have a minus s, and I have 1 here. So the Laplace transform will give minus over s. So the Laplace transform of t squared is 2 over x squared times a minus s plus a minus s over s. So you saw how we were able to transform a piecewise continuous function into a unit step function so that we could easily find their Laplace transform. Thank you very much, students, for paying attention to this video. More practice will give you more confidence to address such exercises. Thank you.